Now I want you to explain about every data written here on the nameplate of another motor for AC induction motor. This is another measurement unit for rated power of motors, horsepower. The horsepower here is 30, and every 1 horsepower is equal to 750 watt. The amperes which is drawn by the motor is 35 at full load. RPM, revolution per minute, 1765 at full load or at full speed. Okay. These are additional data. Okay. Duty, class, insulation, frame, surface factor. The voltage is the voltage or the operating voltage is 460. Oh, the hertz here, which is the motor working on, is 60. This is serial number, this is KVA code, and here the efficiency of the motor, 93. Efficiency is 93%. Okay, let's see now another nameplate of another AC induction motor. Year of production 2011, IB 55, the international protection value, and 42 kilogram is the weight of the motor. Okay. Listen please well to another important parameters which are written on the nameplate of the motors. This table is for the motor, and these values are different according to the different connection of this motor. If you want to connect the motor at delta connection, yes, so you have to connect it at applied voltage of 230 and a frequency of 50, so this motor will consume 5.5 kilowatt and the power factor will be 83%, and then the consumed ampere, which is and then the consumed ampere or the ampere is drawn by this motor at this connection will be 18.9 ampere. And if you want to convert the connection to the delta, so you have to apply the voltage of 400 and at frequency of 50, so this motor will get the same true power or will consume the same true power but with less ampere. So the ampere here at the star connection is less than or fewer than the ampere when delta connection. Okay, there are another connection at a different voltage or a different applied voltage of 460 but at frequency 60 Hertz. So you will need all the consumed kilowatt or the active power of this motor at all the connections are the same. This motor consumed fixed active power, consume true active power at fixed case. Okay, but if you not at start connection at the last one, you will get less power factor here and less ampere. Okay. Please look at these tables. These values of capacitors ratings in kV are required to improve power factor to 95%. If we have many motors rating initially from 75% to 22 kilowatt of rated power kilowatt, okay, and at difference speed, 3 differences of speed here, at 2 pole, 4 pole, 6 pole, okay. This table is easy to choose. Yani if you have a motor of 15 kilowatt and working at and if such for example, if you have a motor of 15 kilowatt operating at speed of 3000 of revolution per minute, it need 4 kVR. Then you must connect capacitor of 4 kVR with the motor. This is table easy instead of calculation at each case. Okay, you can pick up here every power capacitor at every individual rating of any motor. Let's jump to 3-phase motors which working on 230 to 400 volt at 2 values of voltage. Okay, if we have a motor with a power of 75 kilowatt or 100 horsepower, these are measurements of true or active power for the motors. Okay, if we have a motor of 75 kilowatt and this motor working at the speed of rotation 3000 revolution per minute, then you have to look at this table and go to the market and buy power capacitors of 17 kVR. Then you have to connect it in parallel with the motor. These values are calculated. We learned before from the calculations and the equation. Let's see a real motor from a company or a manufacturer is called Erex. This company made a motor. This motor have very wide specifications, output frequency poles for load speed, slave voltage, rated current, locomotive current, full load torque, and etc. Look, 3-phase motor, 3-phase motor, 37% kilowatt. This is a small power. This consumes small power and rotate at 1500 revolution per minute. Contains 4 poles operating at these voltages and at frequency of 50. When you buy a motor, you have to look for and to search and to write very important parameters. You have to know the voltage system. You have to know if the motor is you have to know if the motor you want to use it for 3-phase or 1 phase, and you have to know the frequency of the system of the electrical network which the motor will working on, and you need the power of the motor. You need to determine what is the good power which is useful for you or for the installation. So you can you can get analysis of this information or the data and go to the market and demand this motor.